Alright, welcome back everyone to another video, and this is going to be very interesting. Oracle recently announced their new free tier VMs with ARM processors powered by Ampere Ultra, and these are pretty high-end ARM server kits, and Oracle's just giving them away for free. So I want to do some like light messing about, seeing what it's all about and what the hardware really looks like. So the A1 Flex instance that you get, which I'm SSH'd into, um, is at least 16 core and has 96 gigs of RAM, and this is the free tier one. So I'm not on a paid account. You can literally just get this for free. I'm not sure if the 16 gig one is on like uh, always free instance, but I'm sure they announced like 4 core 24 gig ones as always free. So I'm just running testing this out. We'll see how well it performs and other stuff. But yeah, this is the instance. As you can see, 16 processors and 96 gigs of memory. You name A basically shows you, yeah, it's arc 64. Nothing special here. It is all running on QEMU. So everything here is more or less emulated and running off of the whatever EFI bootloader they're using on QEMU. So you won't have to. It's not a bare metal instance. So but yeah, it's hardware virtualized, so there should not be much performance penalty anywhere. And yeah, so what I really wanted to do, I have HTOP and I have tuxmake, so I wanted to do a comparative kernel build time. So let's see how long it takes. I have tmux, so we can see HTOP go crazy here, and let's split that. Let's run HTOP over here. I've increased the font size so it looks fine when you rewatch it on YouTube. Alright, so cd into Linux, and here we can do time, tuxmake, architecture is ARM64, runner is Podman, and compiler is clang, and I'm just throwing the hardest config I know out there. That's and then what else? To do a separate build directory maybe, but verbose and then build directory. So that should be good. Let's fire this thing up and see how much time it takes. So tuxmake has its own like it gives time for each step of the build, but I just want an overall time in general. Oh, I forgot all mod config. Shit. All right. Okay. C cache. Okay. So rm I forgot to add that. Should help. Alright, now the time doesn't include the podman time. So All right. Yeah, the build is done, and it looks like it took 40 minutes, which is very respectable for an all mod config on an ARM server. So these cores are working hard. For reference, I will start to actually do a couple more builds so I can get an average. The main problem being, you see this broken pipe right here. Yeah, I lost my SSH connection because my network went down. So let me do a few runs on this. Let me do and then I'll come back with the honeycomb, and we'll see how a Cortex A72 fares against this thing. So the Oracle Cloud build is still running. It's on a third lap, so that will be the final build, and then I'll average everything out. It's been around 40 minutes and some seconds on both the previous build, so that's what I'm expecting the third build to be. Right now, I am on the honeycomb. I've SSH'd into the honeycomb. And again, it is another 16-core ARM processor, but this time it's bare metal, not emulated, but not a Neoverse N1. It is a Cortex A72. So there is some IPC, performance and clock performance differences. The Altra has a higher IPC and a higher clock, and we are running at 2 GHz on this one with the Cortex A72. So it would be a nice experiment to see what the difference between these two 16-core ARM servers / workstation environment look like. So let's get started with the all mod config build on this one. So let me split it into two, so you get a nice edge top right here, and on this one you'll get CPU temps as well, because I can get the data for that, although the edge top now does look a bit more crowded than I'd like it to be, but I think that should be fine. So Linux, and then the same exact same command line. So we do tmux tuxmake. Architecture is ARM64, compiler is clang, runner is podman, and then all mod config right there, and what else, verbose, so that it looks nice on video, and then build directory. Just to make everything cleaner. Yep, so let's just ARM64, clang, podman, all mod config. 3, 2, 1. Oops. That, oh, there we go. Right, so it will pull some Docker images. Shouldn't take too long. Yeah, it's done. So I'll leave you all with the build and come back once it's finished. Maybe an hour, maybe an hour and a half. Who knows? This is the first time I'm running it. But just to make things clear, this is running with the clock config that would have come directly from Solidrun. So 2 GHz at 700 MHz bus speed. There are options and ways to move it to 2.2 GHz and 800 MHz bus speed. There are two issues with that. It's not out of the box, and it's at 2.3 I've had some issues with clang builds failing in a spectacular manner, so we are still investigating that, but I'd really like so that's why I took the base sort of clock at which the box actually ships with. So yeah, it's a 2 GHz build. In a future video, let me know if you want a difference between a 2 GHz versus a 2.2 GHz honeycomb, and we'll do the same build and see what the performance looks like. For now, I'll leave you guys with the build. Alright, so the HoneyComb has finished its run and it looks like it's sitting in around 115 minutes, which is quite a lot from what we saw from OCI. But I've run 3 more tests at this point, just to average things out. So 3 on OCI, 3 on Solidrun. And this is what it looks like. Very interesting. So yes, the OCI is higher clocked by a gigahertz and 300 megahertz, but that still doesn't make up for the 3 times faster build time on the OCI. And I think it all boils down to the Neoverse N1 just being faster. The HoneyComb runs on Cortex A72, which is based on ARM v8.0 or .0, which is I think 8 years old at this point. Maybe I'm wrong. So like the first core started showing with ARM v8A or ARM v8.0 around 2013. And so this is basically the same thing. So Neoverse N1, on the other hand, which the OCI runs on with the Ampere Ultra, was announced on February 2019, and it's largely based on Cortex A76, coherent I and D cache with 4-cycle LDUs. L2 cache has been is now from 512 to 1024 kilobyte per core, and using mesh interconnects rather than core clusters. So there were a few differences from A76, but again, the point being it's a much newer design at a much lower node as well. The OCI Ampere Ultra is 7 nanometers and Solidrun HoneyComb LX2K is on 16 nanometer FinFET. So there are differences, and these differences matter. Does that mean that OCI is probably the best choice right now? Maybe in a lot of cases, especially because they have like an always free tier that gives you 4 cores and I don't know 16 gigs of RAM or 24 gigs of RAM. But there is a lot of advantage of by having an actual ARM server in your room. With physical access to it, especially if you're working with device drivers and stuff like that, where you might have to plug in physical devices to try stuff out, or have like a JTAG connection to the CPU or some other hardware debugging capabilities. So there are pros and cons, but this chart is more to show how old Cortex A72 has become and why the ARM ecosystem needs to move away from it. They are doing it in the in the Neoverse or the server market, in the enterprise and server market, but we are still kind of stuck with ARM v8.0 based designs, whether it's Cortex A53, A72, or even A57. But that all needs to change, and this is why I wish Neoverse N1 based designs come in a device that I can keep on my desk or next to my desk at least, and use it as a workstation. But for the time being, as far as ARM workstation are concerned, from price to performance, there's still nothing out there that beats the HoneyComb. So thank you so much for watching. I hope you enjoyed this little comparison, which became a comparison not just between 2 workstation, but between 2 generations of ARM architecture, ARM v8 architecture, and then also between cloud deployment and local workstations. So it was a mixed bag. I hope you all enjoyed it. Thank you so much for watching, and I'll see you all in the next one.